So measure of dispersal is our topic. As I said, we want to start from this point when we meet, and this is where uh, we shall talk about. So if possible, we finish this measure of dispersal, then we introduce quiddness and kurtosis, which is the end of descriptive statistics. Anyway, welcome to this class. Now we'll talk about measure of dispersal. We'll be talking about various items which are very, very important. Now we talk about measure of dispersal. We shall be talking about range, things to do with range, quartiles, deviation, or interquartile range. We also talk about standard deviation and the mean deviation or the average deviation. Now, what is this? What is it? Or what is it that we call measure of dispersal, and why are we looking at it? Now, let us see. Let us see what is this kind of item we are talking about. The measure of dispersal. They are very fast. They'll be very, very fast. So don't worry. If you can harakisha. Now let's define what is measure of dispersal. Let's define what is measure of dispersal, and we say that the measure of dispersal. What's that with the word dispersion? Start with the word start with defining dispersion. So dispersion, let's define what is dispersion. Dispersion. Now, when we talk about dispersion, let me move my logo. Is that one visible? Dispersion. And we say that it's an extent of scatteredness. Refers to the extent, to scatteredness, to scatteredness. Refer the extent to the scatteredness. Or refer to the scatteredness. Refer to the extent of. Refer to the extent of scatteredness of items. Of items around measure around measure of central tendency or the average. Now, what we are trying to say is at what extent does a particular value divert from our averages, or the extent to which our item divert to the measure of the central tendency or the averages. Now that's what we call the scatteredness of item. How is that item scattered from the mean? Or how is that item scattered from the mode, or from whichever you're talking about? Now, that extent to which these items divert from the mean, or from the averages, or from the measure of central tendency is what we call the dispersion. It's what we call the dispersion. Another definition which you can use, we have different definitions which we can use. Degree to which numerical data, another definition refers to degree in which numerical data refers to the degree in which numerical data tend to spread about the average. Tend to spread about the average. About the average. So degree to which numerical data tend to spread about an average, about an average value. An average value. An average value. Now, how is our item spread from our measure of central tendency, or from our averages value, or from our mean? So how is it that our data is spread? So the measure of that spread is what we call the dispersion. Now, this is known as, now the degree to which numerical data tend to spread about the average is also called variation. Also called variation or dispersal. Dispersal of data. Now, it is known as the variation or dispersion of data. Now, measure of dispersal. Measure of dispersal. Measure of dispersion. Now, what is it when you talk about measure of dispersion? It indicates the extent to which individual data differs. It indicates the extent to which individual observation, it indicates the extent to which the individual observation differ on average. Differs on average. Differs on average. Differs on average from mean. From mean or any other form of measured tendency, or any other forms of measures of central tendency. Of central tendency. Hiyo ni ngumu. Or average. Or the average. Or the average. Whichever pronunciation you want to use, it's allowed. So when we say that the measure of dispersal, it indicates the extent to which the individual observation differs on average from mean or any other form of central tendency or a variety or the averages. So the average or the averages, whatever you want to call it. We call it measure of dispersal. We call it measure of dispersal. Okay, that one is fine. That one is okay. Do you have any definition? It is also called measure of variation. Also called. So measure of dispersal is also called measure of variation. Measures of variation or measures of spread or measures of spread. Now, from there, you can define what is dispersion. You can say refer to the extent to which a data is spread around the mean or around the measure of central tendency. That's another way you can define dispersion. That refers to the extent to which the data or the values of the items are spread around the mean or around the measure of central tendency or around the averages. That's okay. So measure of dispersal, it can also be defined as measure of variation or the measure of spread. So it measures how it indicates the extent to which the individual data is spread on the average. So or from the average or from the mean or from any other measure of central tendency that we know. So it measures the extent to which the individual data is spread or how data differs on average.
Excuse me.
Yes.
Hiyo second last line, hiyo light imejifanya nisijui aje.
Ati nini hiyo?
The second last line, hiyo light inaifanya isionekane.
Haionekani?
Light, like toa light.
Oh. Hivyo.
Yes.
Kwa hiyo inaonekana? Sawa sawa, kama inaonekana hivyo haina mambo. So tunasema we're talking about the measure of spread. So how is this data spread around the mean? So when we talk about that kind of a situation, we are talking about the mean. We're talking about the mean. Okay, now I think we go sawa. Now let us continue. Let us see what else can we say. We say when measure of dispersal is expressed by the measure of dispersion is expressed in units, the unit of variable, in the units of variable, the unit of variable, in the unit of variable, it is called, absolute measure of dispersion. Absolute measure of dispersion. That is what you need to know. So when the measure of dispersion is expressed in units, so when the measure of dispersal is in units, is expressed in units, then it is called, you call them absolute measure dispersal. You call them the absolute measure of dispersal. I think you are haina mambo. That one is fine. Let's move on. Just a moment. Okay. Next, talk about what? It is if it is expressed. If it is expressed in form, if it is expressed in form of coefficient, if it is expressed in form of coefficient, ratio, percentage, then it is called, then it is called a relative measure of dispersion. That is called a relative measure of dispersion. That is called relative measure of dispersion. That is called the relative measure of dispersion. Relative measure of dispersion. Think you buy up that point. Any question up to that point? Yes. Any question up to that point? Yes. Any question up to that point? Yes. Any question? Any question up to that point?
No.
No question. I think there is no question on that. That was sour. Now let us move on. Next, we talk significance of measure of dispersal. Significance of measure of dispersal. What are those significance of measure of dispersal? Number one, the significance of measure of dispersal. Number one, it helps to determine the reliability of the variable of the average. It helps in determining. It helps in determining the reliability of the averages. Now, can we derive to measure of central tendency? Now, measure of dispersal, we tell us if we can derive to measure of measure of central tendency. In this case, that is what will help us. Number two, to serve as a basis for control the variability. So it helps or it acts as a basis of control of variability. Now it helps to control the variations that might be there. We'll talk about the data. So it helps to control the variability of the data. It helps compare two or more data. It helps to compare two or more data. It helps to compare two or more data with regard to the variability. With regard to variability. With regard to variability or the variation. Variability. Now kuna giza, but si kama mnaona giza imeingia sana. Inaonekana?
Inaonekana.
Okay. To facilitate the use of statistical measure, so another significance, it helps to facilitate. This is the last one. Facilitate. It helps to facilitate the use of other statistical measure. The use of other statistical measure. So it helps to facilitate the use of other statistical measure. Now we can go to properties. Properties of measure of dispersal. Properties of measure of a good. Properties of a good measure of dispersal. Properties. So properties hazina mambo, ni haraka haraka hizo. Kiendanga. Just we shall state them. Haina mambo mingi. Properties of measure of dispersal. Now allow me to do away with this one. Giza imekuwa mingi bwana. Now properties. Number one. Hizi ni rahisi, properties hazina mambo. Properties number one. It should be simple to understand. It should be simple to understand. Hiyo ina mambo. Number two, it should be easy. Be easy to compute. Number three, it should be rigidly defined. Number four, it should be based. It should be based on each and every item of distribution. Number five, it should be amendable. It should be amenable. Amenable. Not amend. Further algebraic calculation. Algebraic calculation. It should have sampling stability. It should have sampling stability. Then I'm sure it should not. It should not be unduly affected by extreme values. Methods or examples. Methods or examples of measure of dispersion. Number one, you have the range. Number two, quarter deviation. Quartile deviation or inter quartile range. Number three, mean deviation or average deviation. Number four, the normal standard deviation. Standard deviation. Number five, which is the last one, Lorentz curve. I don't think we shall talk about Lorentz curve, but it's part of it. It's part of it, but that will not be our focus. That will not be our focus. That won't be our focus. But anyway, it's part of it. Now, let us start with the first one. Range. Let's start with the first one. Range. 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 That's the first one. The range. Let us define it. Into bracket at. Now, what is this range that we are talking about? What is range? What is range? Range.
Range.
Difference between the smallest and the largest value. Silvio.
Yes.
We
Yes.
say it is the difference between smallest value and largest value. Largest value of a series. Of a series. That's okay. Now, where the data is grouped. Now, where the data is grouped into frequency distribution, into frequency distribution, comma, the range is equal to the range is equal. The range is equal to the difference between between upper boundary upper boundary of the highest class of the highest class and the lower boundary and lower boundary and the lower boundary of the lowest class of the lowest class of the lowest class. Sige, iko sawa. Any question? Now it is clear now from this definition. We can say from this definition it is clear. It is clear now that from that definition, what is it clear? It's clear that we do not take into account the frequencies of the group. That we do not take into consideration frequencies of the group. Now, from that definition, we can clearly say, or we can clearly conclude and say that we do not take into consideration the frequencies of this group. Formula for mean, for mean for range. You can do it here. Range. So what is the formula for range? Now, this one is absolute. Absolute, where we present a figure in the form of absolute. Absolute. L minus S. Now another formula for range, but where our figure is relative form. And you can hapa this one. So here we have our figure is absolute and where our figure is relative. Now this one will form a coefficient of range. The coefficient of range. And now do we find it? Coefficient of range. Coefficient of range. Now how do you find it? Coefficient of range L minus S, the one which is in ratio R plus S. Coefficient of range is equal to L minus S over R plus S. L is equal to largest value of distribution. S, smallest value of distribution. Smallest value of distribution. Nasema L, largest value of the distribution. Now S is smallest value of the distribution. Smallest value of the distribution. Okay. We can look for a question. We can look for a question. Now, let us do an illustration. I think we are fine. Now we can do an illustration. So we do for group data and ungrouped data. Hiyo haina mambo. So allow me to wrap this part, then we do an illustration. So zuri illustration hizi zake zinaisha haraka. Kidogo sana. Don't zidi tu hata inakuja kwa exam, but nipo ujue in case ukienda 2 marks ukianza kuwashangaa utafanyaje? The illustration is our next item. Let us write illustration. The illustration. The following are the prices of shares of ABC. The following are shares, prices of ABC. We have the day and then price. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. The first is 200, 10, 208, 160, 200, 250. Now calculate the range. Now calculate the range from this data required. Find the range. Find the range and coefficient of range. And coefficient of range. That's number one solution. Range. What is the formula for range? Formula for range. L minus what's our L? And what's our S? L is the largest number. And we are to Fiji. Smallest 160. So meaning our range is 250 minus 160, which is an absolute number. So 250 minus 160. 250 minus 160. Idea Amjuna. Harriet. Next. Coefficient of range. You notice L minus S, L plus S. Inakuja ngapi? 250 minus 160. 50 plus 160. Hiyo ni ngapi? Hiyo ni ngapi Ledisha? Chlorine. Give us the answer, Rorin. 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 Okay, Redisha.
0.135.
0.21.
0.135.
Uko sure?
0.135.
0 point. Are you sure? Nashuku your answer. Anyway, sawa. To confirm. So 250 minus 160 divided by 50 plus 160. Mimi niko hapa 0.219. Mimi niko hapa 0.219.
Ni hivyo venye ulipata
0.2195.
95.
2195. Okay. Advantage of range. So that tumalizia range to another item. Advantage of range. Advantage of range. Number one. This is a simple and easy to understand. Simple and easy to understand. Number two, it takes minimum time. It takes minimum time to compute. Disadvantages. 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 It is not based. It is not based on each and every item of distribution. Now, ukiangalia kwa swali yetu is correct. So we have considered only two values. Huyu na huyu. 200 to 8 to 10, 200. It does not consider that figure. It consider only two figures, so it's not a good method because it only considers those two values. It ignores the other values. So you don't consider two values, it ignores the other value. It is subject to fluctuation. It is subjected to fluctuations. It is subject to fluctuation of considerable magnitude. Of considerable magnitude. Of considerable magnitude. From sample to sample. From sample to sample. So it is subject to fluctuation of considerable magnitude from sample to sample. Another one, which we can add, 3, we can talk about it cannot be computed. It cannot be computed in the case of open-ended distribution. Of open-ended distribution. Now, kama you don't understand these items, it is not a requirement here, but you can go and read about sample and sample distribution. which is not a part of the descriptive statistics. It's not part of descriptive statistics. The range, other disadvantage, the range cannot tell us anything. So the range cannot tell us anything about the character of the distribution. About character of distribution. So the range cannot tell us anything about the character of distribution within two extreme observation. Within two extreme observation. Now, for example, Hapa, this 90, what does it tell us? Yes, we know this is the scatteredness, but what does it tell us? What does it tell us? Now, we cannot actually say what it tells us because you might find, now, if maybe we include Sunday, for example, let us say we include Sunday, and then for Sunday to 90. Now, the range you talk from 90 to 120. Now, even when this figure is changing from time to time, small figures and big figure, that range cannot tell us exactly what is it that we are talking about. It's very hard. Let's do another illustration. Let's do another illustration where we have a continuous data. So illustration. Now where we have a continuous data. So illustration. In the case where we have a continuous data. Let us write this illustration down. Then we answer the question together. Now calculate the range and the coefficient of range from the following data. So calculate the range and the coefficient of range from the following data. So this is the data. You have the marks. Then students 10 to 20, 8, 20 to 30, 10, 30 to 40, 12, 40 to 50, 8, 50 to 60, 4. So we are required from that data to calculate the range and the coefficient of range. Solutions. Now, someone to compute for us. Go on the computer. Yes. Someone to compute for us. Mapata ngapi?
Fifty.
Unaona?
Yes.
Now range Notice our M, notice our S. Now our M is the upper limit, which is 50 plus 60 divided by 2. Then our smallest figure is the lowest boundary, which is 10 plus 20 divided by 2. That would be our range. Itakuwa 55 minus 15. Aya, coefficient of range. Itakuwa ni 55 minus 15. 55 plus 15. So hizo answer ni ngapi? Give us the answer. Yes. So you need to know that NB, L is the midpoint of the highest cross boundary. Then S is the midpoint of the lower. Cross boundary. Now, what is the answer?
Range is 40, coefficient of range is 0.57.
0.07.
0.57.
Yeah, Dana.
Range will be 40. 0.57. 57.
0.57.
Yeah.
That marks the end of range. Any question? Now, uses of range. Are you tunafanya baadaye? Uses of range tuangalia baadaye. Let's go to quartile deviation. Quartile deviation. Quartile. Quartile inaandikwaje? The word quart imeandika mbaya. Quartile deviation. Quartile deviation, we say, is also called. It is also called semi-interquartile range. Semi-interquartile. Semi-interquartile range. It's also called semi-interquartile range. It is a measure of dispersal summation of dispersal based on upper quartile, based on upper quartile. Upper quartile. Remember upper quartile tulikuwa tumeshafanya Q3 upper quartile and lower quartile. And lower quartile. Lower quartile ilikuwa Q what? Someone to remind us.
Q1.
Q1. Naona mnaendelea vizuri. Now, the difference between Q3 and Q1 is called interquartile range. Interquartile range. It's called interquartile range. And 1/2 of the range is called quartile deviation, QD. Is called the quartile. And get in full. Quartile deviation. So the difference between upper quartile and the lower quartile is called the range. But when you multiply a half with that range, we shall get quartile deviation. So this is what we mean. Interquartile range, interquartile range. Q3 plus Q1. I have quartile deviation. Quartile deviation. Tumesema ni a half of Q3 minus Q1. Which is the same as saying Q3 minus Q1 divided by 2. Divided by 2. Q3 is the upper quartile. Q1 is the lower quartile. It's the lower quartile. What else should we add? NB. They andika wapi. Find a space so that we can do some questions here. We're going to find some maswali. We find a past paper. We just do it from the past paper. Ama tufanye illustration, unaonaje? Tuendelee na illustration ilikuwa tunafanya ama tuendelee past paper kwanza? Yes, watu wangu. Kaa mbongi. Eh? Ati nani wanaongea? Okay. Let me wrap this part. We give this NB. NB NB NB. Say when QD when QD when QD is very small, is very small, it describes high uniformity, high uniformity or small variation or small variation of center of center 50% of the item, 50% of items and ID and high QD means that the variation among centers item is large. The variation among center among central item are large. Among central item are large. That's okay. So when QD is very small, describe uniformity or smaller variation of items. But when QD is big or is high, it means that we have a variation among center item and they are large. And those center items or those items are large. Illustration. Find the quarter deviation. Find quarter deviation. Find quarter deviation and its coefficient. And its coefficient from the following. From the following data. Now we have the data here, marked. $20, $28, $40, $12, $30, $15, $50. Now find the solution. Now what's the first solution? Arrange the data in ascending order. Now arrange the data in ascending order. Now go calculate median. So quarter relates to the median. So in this kind of data we arrange. Rather than 12, another 15, 30, 30, 40, abandonment, 12, 15, 20, 28, 30, 40, or 50. Hapa hivyo. So 12, 15, 20, 28, 30, 40, 50. So rather than Q1, remember our QD, the Q minus Q1. And then the coefficient of QD, the Q3 minus Q1 divided by 2. So then the first one, then after Q3. Now Q3, because this data is individual data, itakuwa ni 3n/4. Now 3n/4. What's the number of n? So 1, 2, 3, 4, 5, 6, 7. So kwanza hiyo saba ni saba. Ukiacha zote zinakuja 7 and 7. Now we are supposed to be now hapa ilikuwa hivi. Hapa ndakuwa nawadanganya kabisa. Kama ingekuwa 8, kama n for example ingekuwa 8. Tungetumia formula n/2. But because it's an odd number, itakuwa ni n plus 1/2. So hapa itakuwa ni n plus 1/2. Tunataka confirm huko nyuma vilikuwa tunafanya. You can go back. Huko nyuma confirm. Kama ilikuwa tunafanya hivyo. You can go back up to this is called zilikuwa median. Now find that one. Nienda kwa hiyo median yetu nione. How are we doing it? For individual data. Nime 1, 2. Nivo. We are doing this way. So it's our median, which is our Q3. Niwashuku. Itakuwaje wewe? Hebu nikumbushe. Let's go back to the median. Let's go back to the median from your notes. Open your median and then uende kwa part ya quartiles. Uende kwa part ya quartiles. Let me confirm how we were supposed to find it for individual data. Quartiles. Okay, nimeona. Quarter 3. Now itakuwa hivi. Let me go back nitumie hiyo formula. Itakuwa hivi. Itakuwa ni the size of n plus 1/4 of the end item. Is that correct? Ama itakuwa 3n? For the third quarter. Okay, third. Itakuwa 3n, sivyo? 3n. Yes. Now let's find it. Itakuwa the size of
3n.
Yes, nimeweka 3n. So 3 is 7 plus 1. So 3 times 7 plus 1 over 4. Nakuja ngapi hiyo? Lakini naona hapo wanasema
11.
kwa hiyo formula yetu yenye iko na 3 plus 1 wanaweka hapa 3. Ndio tukufanya swali iko na odd. Wanaweka hapo. Is that correct?
Oh, okay.
Yes. The size of 3 n plus 1 kumaanisha itakuwa inakaa hivi. Itakuwa inakaa hivi 3 n plus 1. Na our n ngapi? Our n is 7 plus 1 over 4 and item. Itakuwaje? Itakuwa ni 7 plus 1 divided by 4 times
7.
3, which is 6. Which is 6. So 6 in a layer to which point? Where does 6 rise? So 1, 2, 3, 4, 5, 6. Does it rise here? Can you say that the figure is 40?
6.
Eh.
Yes.
What about quarter 1? Quarter 1. The size of itakuwa to direct n plus 1. Is that correct? Itakuja ngapi? Itakuja 2. Where does the 2 rise? 1, 2. How do you say our answer is 15? How do you say that our answer is 15? Yes. Now find our QD. 40 minus 15. Then coefficient of QD is 40 minus 15 over 2. So what is the answer? Coefficient of deviation. Now this is supposed to be coefficient of deviation, this one. Coefficient of deviation. Coefficient of deviation. Coefficient of deviation. Coefficient of deviation. Then you can also be asked to compute. You can also be asked to compute coefficient. So when we change pale juu, coefficient of quartile deviation. Now in this case, itakuwa ni Q1, Q3 minus Q1 over Q3 plus Q1. That is coefficient of quartile deviation. So we have quartile deviation, which is also called the interquartile range. We also call it interquartile. 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 Interquota inaandikwaje? 4 times 4, kuna A hapa. Hii ni A of R, C R range. So another name of quarter deviation. Another name of quarter deviation is QD. Quarter deviation is interquartile range. Coefficient of deviation, D means deviation. This one means D means deviation. The coefficient of deviation is 40 minus 15 over 2. Then the coefficient of quarter deviation, one is 40 minus 15 over 40 plus 15. 40 plus 15. That is. But that one is applicable where we have one figure or one item. That is applicable where we have this kind of a figure, an individual figure. An individual figure. Now, I want us to go to the past paper, but before we go to the past paper, so another formula which you can be asked, but utafanya baadaye. It's not applicable in this kind of a data. We cannot use in this kind of a data. We can only use it when the data is continuous. Let us do another illustration. Another illustration. Allow me to drop this one so that we can go now to our past paper. Illustration. Okay. Illustration. Illustration. QD and coefficient of QD from the following data. From the following. So compute QD and coefficient of QD from that data. Now tufanye kwanza and then tumalize tuende kwa so this one tunaenda kwa the discrete data. Discrete type of a data or series. Ile nimetoka kufanya sahihi ni individual. Yenye nimetoka kufanya sahihi ilikuwa individual series. Na tuende kwa max and then frequency. Then ni 4. 20 ni 7. 30 ni 15. 40 ni 8. 50 ni 7. 8 ni just 2 guys. 20, 30, 40, 50, 10, 20, 30, 40, 10, 20, 30, 40, 50. 10, 20, 30, 40, 50, up to 8, 4, 7, 15, 8, 7, 2. Solution. Solutions. Now, max. We're gonna max at our x, then frequency at our f, then cumulative frequency. Cumulative frequency. That's our CF. We've got 10, 20, 30, 40, 50, and 80. Because we're gonna 4, 7, 15, 8, 7, and 2. Cumulative. 7 plus 4, 11. 11 plus 15, 26. 26 plus 8, which is 34. 34 plus 7, 41. 41 plus 2, 43. 43. Now, we have to find the QD. We know that QD is Q3 minus Q1. And we need to find the Q3. We need to measure the size of 3 n plus 1. 1, 2, 3, 4. Actually, sorry. This one is gonna frequency. Now our n here is our rate of frequency. So let us add them together. 43. So this frequency ukiangalia, it's an odd. So we need to add 1 or something odd. Kama ni even, it's ni n over 2. But because it's n plus, so it is odd, we need to add 1 of the nth item. So itakuwa ngapi? Itakuwa size of
Divide by 4.
divided by 4. 3. Now our n 43 plus 1 over 4. And the item. Itakuwa ngapi hiyo? Unapata changamuke
33.
30?
3.
33. I see now 43 plus 1 plus 1 divided by 4. All 11, 33. Now where does it lie? 33 is the item. Now lie wapi? Where 33 na lie wapi for our cumulative?
In the class of 40.
Yes.
Hapo kwa 40.
Ati ngapi? Na lie hapa.
Hapo kwa 40.
So lie kwa 34. Sivyo? So kumaanisha our Q3 ni 40. Alina kwa Q1 size of n plus 1 over 2. Sababu ni odd of the and the item. Itakuwa ngapi? Size of 43 plus 1 over 2. So ni ngapi?
20.
Okay?
It will be 11.
Hapa 20.
11.
Hapa 20.
11. We'll divide by 4.
Oh, jini quarter. Naona uko rada. Jana zilikuwa nimeona. Now where does this lie? That is so good. Naona uko rada sana. Now our Q1 itakuwa ngapi?
20.
20. What will be a QD? Ni 40 minus 20, which is 20. Next one is coefficient of QD. Ni 40 minus 20 over 40 plus 20. Pata ngapi hiyo? Ngapi?
0.33.
0.33. Now, imagine a continuous series. Tumalizie na continuous series. Now complete with continuous series. That will be the end of the quarter deviation. Quarter deviation. That will be the end of quarter deviation. Illustration. Number is for, we are now on continuous series. What will be our last illustration? Continuous series. Continuous series. Okay. Illustration. Compute QD. Compute QD and coefficient of QD from the following. From the following data. Now we have our figure. Yeah. Read the marks. Or read the class. Read the interval. Interval and frequency. So 10, 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 10 to 20 to 30, 30 to 40, 40 to 50. Ni maajabu. Kwa meka 60, 70, 7 to 8. Alimuka hiyo katikati. 12, 19, 5, 12, 19, 5, 10, 9, 10, 9, 6. Solutions. 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 Now we need to find the value of f. The midpoint, Sipio. Is that necessary?
No.
Is it necessary?
No.
Yes, no, it's not necessary. So we just need cumulative frequency. Frequency and cumulative frequency. So we can say our interval 10 to 20, 20 to 30, 30 to 40, 40 to 50, 60 to 70, then 70 to 80. Then you have our frequency. We have 12, 19, 5, 10, 9, and 6. Then our cumulative frequency. 12 plus 9?
31.
31. Plus 5?
36.
36. Plus 10?
46.
46. Plus 5?
55.
55. Then ya mwisho.
61.
Now, we know that QD is Q3 minus Q1. Now, Q3 is the size of 3. Anything happy? 1, 2, 3, 4, 5, 6. Hiyo ina 1. Sivyo? Kwa hivyo itakuwa ni n over 4. Is that correct? Is that correct?
It will be
No.
n plus 1. Any odd number.
Ni ngapi? 1, 2, 3, 4, 5, 6. Ni 6.
No, n is summation of
Oh.
frequency.
Oh, are we not choosing the
Oh,
frequency?
sorry. We need to find the total frequency. We are using total frequency because of frequency. Ni ngapi?
61.
Sawa sawa. Now because of this kind of an item, we need to find the Q3. Itakuwa ni L plus I over F M minus. Now this one is our M. Sivyo? Umesema hivyo? Niko sawa?
Yes.
Aya. Tafute M. 3, 61 plus 1 over 4. So 61 plus 1 divided by 4 times 3. 46. 25. Where does it lie? 46.5. Nadai wapi hiyo?
Or 55.
Kwa 55.
Yes.
Yeah.
So kumaanisha tukienda kwa 55 hapa. Now L itakuwa ngapi? What will be our L?
60.
60.
Yes.
Kwa 60. Aya. Our I
10.
10. Our M. Our C.
46.
So tuweke. Our Q3 itakuwa ni 60 plus 10 over F. Our frequency ni 9. Hii hapa. 9. 46.5 minus 46. Inakuja ngapi? 46.5 minus 46 times 10 divided by 9 plus 60.
60 point.
60.56. Point Tupate hivyo. Q1 itakuwa size of n plus 1 over 4. The end item. Itakuwa ngapi hiyo? Size of 61 plus 1 over 4. So 61 plus 1 divided by 4. 15.5. 15.5 inaingia wapi? Hapo? Yes?
Yes.
So our L ni ngapi? 20. I ni 10. Frequency 19. Aya. M 15.5. C 12. Is C 12? C 12.
Yes.
Now let us find now L. Q1 is equal to L plus I over F M minus C. So L yetu maana ni 20 plus 10 over 19, 15.5 minus 12. So 15.5 minus 12 times 10 divided by 19 plus 20. By 21.84. 21.84. 21.84. Now we can find now this one hapa. Q3 ni 60.56 minus 21.84. So what will be your QD?
38.72.
13.33.
38.72.
38.72.
Yes.
So tunapata 60.56 minus 1.84, which means that 8.72. Aya, coefficient of QD equal to 38.72 over 60.56 plus 21.84. Napata ngapi?
0.47.
0.47.
I have a question.
0.47. 0.47. 0.47. Any
I
question?
have a question.
Yes.
Tukiandika kwa notes, tumesema
Eh.
formula ya quartile deviation ni Q3 minus Q1 divide by 2. Sasa interquartile range ndo Q3 minus Q1.
Tuko na formula tatu. Tuko na interquartile Q3 minus Q1. Sivyo? Now quartile deviation. Now we have this is supposed to be divided by 2. Sivyo? Supposed to be that way. Sivyo?
So all along we've been calculating interquartile range.
Interquartile ndio Q1 minus Q3 minus Q1. Yes. So correct that one. So interquartile. So correct that one on your side. Ni Q3 minus Q1. QD divided by 2. So for QD inafaa tukuwe na 2. Anyway, you can correct that one. That one is not an issue. That one is okay. See, iko sawa hadi hapo? Iko sawa hadi hapo? Mwenye alikuwa ameuliza hiyo swali. Uko sawa sasa?
Yeah.
Now, let me give you just assignment to get kufanya kesho. So let me give you some assignments. Let me present my screen. And kindly make sure you do them before kesho. Now, can you see my board, my screen? Unaona?
Yes.
Now tuanze Rafiki. August 2024. That question number 1B. Now 1B, can you do 1B? Food. Apart from part 5. Anasema quartile coefficient of skewness. Hapa anasema quartile, hajauliza deviation anyway ni sawa. The quartile coefficient of skewness tutafanya. But I think you can do part 1, 2, and 3. Iko sawa? Part 4 ndo tutafanya skewness. Don't worry about it. Let's go to this sitting April 2024. Third division. Hiyo ndio next. Tutafanya which will be tomorrow. Third division. Hiyo haina mambo. This sitting here December 2023. Do you have a question? Now, can you do that question apart from part 4 and maybe part 3 or maybe part 2 here? Standard deviation. So, can you only do part 1? Mean. So, I'm going to find standard deviation. Can you do part 2, part A? Find the mean.
Yes.
August 2023. Tulikuwa tushaangalia ya ina mambo. Make sure you do this question. Hii nilikuwa nimwambia P15, P5 na P85. Hii nilikuwa nishawaambia. Let us ignore that one. April 2023. Now that question. Can you do that question? Yes? Yes or no? Mjaribu tuone kesho. Mjaribu.
Which sitting?
Yes.
Sitting gun?
Ni April 2024. April 2023. April 2023. Question number 3B. Number 2B. Number 2B. So mjaribu hiyo. But hiyo tushafanya media na mode. So wena mjaribu, ndio tufanye kesho. Haya, another one which I want you to go and do. Ndio tufanye pia kesho. Now look at that question. Can you do that question? Can you do that question? Part 1 and part 2. The model and the quarter deviation. Brenda? Brenda.
Yes.
So we shall do part 3 when we do screeners. For now, we ignore that one. Now that is another one. We're going to check. Unapatana hivyo. By August 2022. You have a question? Now, that one, question number B. Ezra, can you do that one? Model, medium, and quarter deviation. Ezra. Unakatika.
Pardon.
Can you do that question? This one. Model class, model production, median, and quarter deviation. Is that possible?
Yes.
Yeah. Now, this one is standard deviation. Tafanya kesho. Ya ina mambo. This one can ingilia hapa ni standard deviation. Tafanya kesho. Aya, December 2021. Aya, can you do that one? Mary, is this one possible? Question number 5. Wanakwambia 25 percentile, 75 percentile, second decile, and 8th
Yes.
decile. Hiyo haina mambo, hiyo iko sawa. Na hapo usiona kama ametwist hapa, hiyo haina mambo. From 20 to 60, 60 to 100, 100 to 140. So hakuna kitu tofauti hapa. Hata kama ameweka hapo katikati hizo ma x. There's nothing to fear. Now, we meet tomorrow. We'll introduce a deviation, then tumalize, then tuingie screeners and kurtosis very early in the morning, so that tumalize hii topic, then tumalize probability kwenye tukianga. So I want to finish probability kwenye tukia and some other items. So that tomorrow, nitakuwa nimemaliza kila kitu. So in case you need the video, I will upload all the videos on Telegram, so that you can also revisit in case you want to review them. So with that one, let us meet tomorrow. We complete QA so that we remain with Econ over the weekend. Anyway, have a good night. We shall meet tomorrow.